Hi, my name is Shayan. I'm a research fellow at the Institute for Frontier Materials at Deakin University, and my research is on fibers from a wide range of nanomaterials for wearable applications. My work is making technology wearable. I would like to make fabrics that can act as sensors, batteries, and other electronic functionalities. There's a need for this because traditional electronic devices such as batteries and sensors aren't flexible, and they result in hard-to-wear clothes. I'm using new nanomaterials that can be used into functional fibers that can ultimately be worn. My background is textile engineering. I did bachelor's and master's degree on fiber science. During my PhD, I've worked on conducting polymers and made fibers out of those. I was interested in conducting polymers because polymers are known to be insulating materials, and having polymers that can conduct electricity was really interesting to me because we could make fibers that are conductive and that can be made into textiles. Since I joined the Institute for Frontier Materials at Deakin University, I made conductive fibers from graphene. Why I was interested in graphene was because of its high conductivity and high energy storing properties. Graphene is a single-layer carbon that is found in pencil tips. When you write with your pencil, you lay down many layers of graphite, which is composed of thousands of layers of graphene. My work focuses on individual layer of graphene, which is tens of thousands of times thinner than an A4 paper. To turn graphene into fibers, I used a process called wet spinning that is used in industry for making everyday fibers. I modified the wet spinning process to be suitable for graphene fiber fabrication. So I start from a graphene solution, and I inject the solution through a needle to a bath called coagulation bath. And it happened that when you force the graphene solution through a needle, they can easily fold and crumple and hold on to each other to form a continuous thread that can be continuously collected on a roller. After making graphene fibers, I was able to knit those into fabrics. I was really excited to see that these graphene fibers were conductive, and they could store some charges, and they were flexible and comfortable. So that solved my initial problem of making flexible and comfortable energy storing fibers. But unfortunately, the energy storing properties of graphene fibers were not as high as I expected. Then I came across with a material with higher energy storing properties called MXene. MXene is a sheet-like nano material similar to graphene, but it's composed of carbon and titanium. I thought that I could simply substitute graphene with MXene and get MXene fibers. But unfortunately, it wasn't that simple because MXene sheets were much smaller than graphene sheets, and they couldn't hold on to each other to make a continuous fiber. Because of my previous experience with graphene fibers, I thought of using graphene sheets to connect smaller MXene sheets, and I was able to get fibers that had 88% of MXene, and the energy storing properties of the fibers were 10 times higher than graphene fibers. So the next step of the project is making more MXene fibers, making it washable and affordable, so that we can create larger fabrics so that they can meet the energy demands of future wearable technologies. The other project that I'm working on is making fibers that can monitor body movements so that they can be used for injury prevention and monitoring vital signs such as heart rate.